So welcome everyone. Thanks for joining us. As you've just heard the disclaimer, this meeting is being recorded. So if you're not comfortable, please make sure to keep your cameras off as we will be sharing this recording after the plenary. So I would like to warmly welcome you to the repeat session of the Harmonized Terminologies and Schemas for Fair Data in Material Science and Related Domains Working Group. This working group is just getting started, so this is part of the kickoff session. And before we start and I pass the floor on to the working group chairs, I would like to briefly share some housekeeping notes. As I've mentioned, this meeting is being recorded and we will make the recording publicly available. We have prepared some collaborative notes, which I will share in the chat shortly. And please make sure to log in, sign your name and contact details in the collaborative notes. And also please feel free to actively participate in the note taking. And we're really looking forward to an engaging discussion as with our first session. And lastly, this meeting is taking place according to the RDA Code of Conduct, which I will also place in the chat. So with these very brief notes, I would like to pass the floor on to Zachary Trott, one of our co-chairs of this working group, to start our session off. Thank you very much for joining and for your attention.
And thank you for the introduction. So I'm working on sharing my screen, and can somebody again confirm that we're seeing the slideshow? Yeah,
It's perfect. Thank you.
Yep. As was mentioned, this is a repeat session of the kickoff of the Harmonized Terminologies for Materials Science and Related Domains. The first meeting was in a time zone that was friendly for Europe, Asia, and Oceania. And this repeat is designed to be time zone friendly for the Americas and Europe. So we had about, I think, 18 to 20 people in the first session, and hopefully we get new people in this session. All right, so welcome. So the chairs of this group, and let me minimize Zoom, include people from the UK, the United States, Japan, and Korea. So we have reasonable representation on different continents and regions of the globe, and a huge thanks to the Tiger support that we've received. I think this is an amazing thing that's being provided through RDA. And oops. And just a brief history. So this working group is not the first time that materials and chemistry has had a footprint within RDA. RDA itself was founded in 2013, and quite early on, an interest group was founded around materials data, and it continues to this day. Likewise, a interest group was founded in chemistry in 2016. And some working groups that got founded was the International Materials Resource Registry Working Group, which stood up 2 registries and finally published its final recommendations, were approved in 2021. And then sort of leading up to this particular working group, there were 2 BOFs. One of them was at P18 that I sort of led in 2021, and then one at P20 that Gerhard led, and ultimately leading to this working group today. So this working group is really going to sort of leverage what has been done and try to fill gaps where we see gaps. So this is the agenda for this session. Gonna present a quick overview of some of the things we've been doing, and collect some input from you quickly with a Mentimeter, and then get into some greater details of the work that we've been doing so far, present some clarifications, and then finally, most of the session will not be slides. It will be talking and working in the collaborative notes. And of course, you can look up on the upper part of those collaborative notes what was discussed last week, and then hopefully we'll gather input in the bottom part of the document for the repeat session. And if anybody has any clarifying questions, I'm more than happy to take those while I'm speaking. We don't need to wait to the end. All right. So the ultimate goal of this working group is shown on the far right, where we want to increase the uptake of the fair data principles in chemical and materials research. So that's our high level goal on the right, and we'll do that by collecting and reviewing existing semantic artifacts in materials and chemistry. We'll propose and verify best practices. Um, uh, for practitioners to improve fair data based on these semantic artifacts, identify needs for harmonization of these semantic artifacts, and then demonstrate successful implementation of these things. So one of the things we'll do is a review and fair maturity assessment of the semantic artifacts themselves. So this working group is focused on the semantic aspects, things like terminologies, schema, taxonomies, and their level of fairness. So not specifically on the data, but the fairness of the semantic assets. We'll publish a best practice recommendation document about regarding how to make these things fair, and finally start working on new harmonized semantic artifacts. So the work that we're doing is divided up into um, four streams, and we have a Gantt chart that you can look at online. So stream A is collecting and reviewing existing semantic artifacts. Stream B is best practices for materials practitioners. And then stream C is really getting into potentially making new semantic artifacts or harmonizations and crosswalks. And finally, stream D, it would be sort of post wrap up, demonstrating these things. So this is just a zoomed in view, and we're trying to structure the major milestones of our work around the plenary meetings. So right now we're sort of counting plenary 22 right here as sort of the kickoff of this working group. We've done some of the initial preparatory work in collecting things, and we're going to do some of that again today with all of you. And now in the next 6 months, between hopefully now and November, we're going to make a lot of progress on some detailed aspects of stream A and stream B. So our hope is that sometime around the November plenary in Costa Rica, we can transition from significant progress on stream A and stream B into progress on stream C. That's our hope, and we'll see how it goes. All right, review of related activities across and beyond RDA. So there's a number of interest groups and working groups that have relevant input to what this group will be working on and recommending, and they're listed here. I don't need to speak them all. You can read what's there, but a lot of work has been done within RDA that's relevant to what this group is doing. Likewise, outside of RDA, there's a number of groups that are making specific progress in semantic artifacts in the material spaces, or more broadly, that is relevant to this working group. So we have our eye on this, and one of the and coming up when we run the Menti, we want to make sure that we haven't missed any. Some existing services where semantic artifacts could potentially live or be potentially used are listed here. Things like the Materials Resource Registry, Map Portal, the NFD terminology service, and the list goes on. Things like the metadata standards catalog, and fair sharing came out of RDA. So there's a lot of services out there. And again, if you know of any, please make sure you put the URL or a description when we collect with Menti or in the collaborative notes. Oops. And now we are ready to do a little Menti exercise. So I'm going to stop sharing because I think my colleague is going to take the lead on that one. Is that right?
Exactly. So let me quickly share my screen and present. All right, I think it should be in full screen now. So I'm going to give you a minute to log in and participate in our quick Menti. So just give me a thumbs up if you've joined, so I know that you're all logged in good time. There's 1, 2, great. Gonna give it another minute to make sure you all have enough time to join us. Okay, so the QR code is actually on the next slide as well, so the benefit of time. And just as a warm-up to get us started, best meal while on travel, where and what? Go one. Not in Valencia, which is the, the Valenciana. Okay, but it's equally good. Ooh, nice. Very good. Oh, just a few more seconds. Trying to get some ideas as well for future travel. Good. Okay. All right, so I think we can move on. So who else is working on this? What other initiatives are you aware of? A fair amount. Interesting. Core. Okay.
I just put that on there also for our own records. We can add it. I just heard about this as new. So
Okay, perfect. Thank you, Gerhard. I'll make sure to copy those over. But the people that contributed can do so as well in the collaborative notes that can be found in the chats. Ideally with links, if you can, that would be really helpful. Okay, so I think we can move on if there are no other, or we can give it a couple more seconds. Okay. So next question. What are major efforts and services that you are aware of in the field? Thank you for sharing the link. I'll pick that up after we finish our for our notes. Any other contributions before we move on? As a reminder, you can also directly add them to the collaborative notes, or also speaking up is always an option if you prefer that. Okay. Okay, so if there's nothing else, we'll move on to the last bit, which is open questions and comments that you would like to address during the session. So if nothing comes immediate to mind, you can think about it and contribute to the collaborative notes, your questions or the Zoom chat, and I'll make sure to transfer them over. And Zach, if you agree, I'll pass the floor on to you again.
Yeah, that
so we
sounds
can
good.
resume. Okay, perfect. Thank you. All right. Stop sharing. All right.
All right, are we back to my slides?
Yes, perfect.
Okay. So we do have a document where we've been collecting existing resources, services, groups, so on and so forth. So I'm gonna pause here if folks want to type in that tiny URL or use that QR code, or if you have access to this slide deck, you can click on the link. You're welcome to add to this list. View the list that we have to help you sort of form your response and reaction to what we're working on. And you're welcome to type into this document or the collaborative notes. Some key definitions and clarifications. So I always like to sort of show the fair data principles to remind everyone that they are quite detailed, and there's 15 specific elements or attributes of the fair data principles. And I wanted to take this time to really highlight in the context of the fair data principles what this group is really working on. First and foremost, pointing out that the fair data principles themselves are recursive in the sense that I2 states that data and metadata use vocabularies, that the vocabularies themselves follow the fair data principles. And I would say that this is one of the primary focuses of this group, is thinking about how the fair data principles apply to vocabularies, schemas, ontologies, the broader ecosystem of semantic artifacts. And of course, placing an emphasis on these two elements and reusability, the domain relevance. Obviously, we're working in materials and chemistry, and the making sure that thinking about crosswalks and the richness and depth of these semantic artifacts. All right, so some work has already been done in this space. So thinking about the maturity of semantic artifacts, there's already been a whole entire working group and output thinking about the maturity of data itself. So there is a maturity model for data to sort of judge the fairness of the data, and thinking about the same thing for material semantic artifacts is a focus of this group. If there has been work already done on the fair maturity of semantic artifacts more broadly, we'll definitely sort of build upon that. But we're thinking about it from the perspective of the semantic artifacts that are being used in the materials community, and ensuring and quantifying and having metrics for the fairness, such that for the small number of people who like to work on material semantic artifacts, they have sort of a model for how they publish and disseminate that semantic artifact to make it more fair. Another thing that's, I think, relevant to this group and relevant to sort of maturity assessments. So there is this thing called the fair implementation profile, which sort of is a description of what you're doing to try to make your data fair. And potentially this group could think about a similar sort of worksheet or profile for semantic artifacts, just to sort of get that conversation started of what are people doing now. So yeah, should this, like the question is, should this be a focus of the group? One thing to point out is that there's different types of semantic artifacts, and I pulled a few sort of terms and definitions from various places, where controlled vocabulary is just a set of terms, a glossary, terms with definitions, and of course ontologies have rich relationships. I think we're familiar with schemas, which both enable validation and define the structure. So semantic artifacts fall on a spectrum based on their expressivity, and I think most people sort of realize this. But for us, that sort of means that there's two different spectrums here that are orthogonal. So on one axis, you have the fair maturity spectrum, where you could have a semantic artifact that's really not findable or accessible, like maybe it's just a description in a paper. And of course, the other axis, sort of orthogonal to that, is the semantic expressivity, going from low expressivity, like a simple taxonomy, to high expressivity, such as a ontology. So our group is about moving things to the right. So low expressivity semantic artifacts still have their place in this world, and our group is about moving things to the right, increasing the fair maturity, whether they have low expressivity or high expressivity, and then of course potentially working on other semantic artifacts that make crosswalks between those levels of expressivity, or just artifacts regardless of their expressivity. All right, so I'm gonna stop sharing unless there's any clarifying questions before I stop sharing, because we're at the point of jumping into the shared meeting notes, and I believe this link has been pasted many times into chat by Athena. So let's see. Thoughts, questions, concerns, reaction, and if anybody would like to introduce themselves and say hello. So we have 14 participants, which I think is a good turnout. We had, I think, 18 in the last session. It's great to see. I see somebody from Network, and I'm glad you're here. I'm gonna move over. For some reason, I'm having trouble getting back to. All right. So I am in the collaborative notes. We got the topics from Mentimeter that are getting pasted in. So one thing that was mentioned during the Menti session was Matt Core, and I think that I had not heard of that before. And would the person who mentioned that mind unmuting and saying a few words? If you're not comfortable unmuting, feel free to give us a little more detail in the collaborative notes. So let's go to the first sort of question for the collaborative session. So what makes a semantic asset findable? I think we know what makes our data findable, things like persistent identifiers. It's been indexed in some kind of service, or it's registered in some kind of service. What about findability for semantic assets? So I'm going to put something in just to get the conversation started. Persistent identifiers for both overall asset and terms, etc. within it. And again, folks are more than encouraged to unmute and say hello, so we can have a a session as lively and as interesting as if we were in person.
It would it would interest me how you find semantic assets in practice.
Well, I guess they need to have good metadata describing the asset and published somewhere where they're being indexed.
So that that means starting with the search engine.
Yep.
Yeah. Because that's for me, it's always like the question is like, okay, do I have somewhere I go first, like a portal, now there's map portal, industry portal, terminology services, and then search there. And that means I have, now 4 or 5 of those in that could be relevant, and I start search, which I do. Or, go to basically Google it.
Yep. I think in an ideal world, these services like that you mentioned would have in and of themselves good search engine optimization,
Exactly.
such that the generalist search engines are indexing these things and enabling at least a starting point to search, and maybe the first search brings you from a major search engine to these specialized services, and then if need be, you can sort of navigate inside those things.
I think that's what we found in one of the papers that we published, was how researchers work. It's quite often Google is the first stop.
Yeah, so then it really relies on what Sachs has said. Yeah. Because I think it was also one of the kind of common issues in one of the fair semantics from the fair semantics recommendations. There's kind of a lack of a common API, across these different kind of portals and services. So, I mean, that would, of course, yeah. I mean, I guess it's the same with metadata as it is with data in the end, of course. Yeah.
I'll just put the link to that paper in the chat.
Thank you. That's really useful.
But that was like a year and a half ago. Who knows what people do now? Things change.
Probably not.
Yeah.
Let's go ahead and move on to the next question in the collaborative notes. What makes a semantic asset accessible?
Hi, this is Anu, and I was wondering, let me just introduce myself. I'm the tab liaison for the working group. So I have no domain expertise in this area. I come from a biomedical background, but I was wondering, for biomedicine at least, there is a significant difference between fairness as it's attributed to data versus fairness as it's attributed to semantic artifacts. So I wasn't sure if that's the case also in this area, or whether it's pretty similar.
Well, could you tell us more about those two fronts in biomedicine, fairness for semantic artifacts and fairness for data? This group is really focused on, I think, primarily on fairness for semantic artifacts. And of course, I think closer to your domain, I think we're familiar with like BioPortal.
Correct. I was
yeah.
gonna say, so you have BioPortal, and a lot of data from biomedical domain has like a lot of privacy concerns, etc. So accessibility is not straightforward. Whereas for semantic artifacts, typically they are provided under open access, right?
Yeah.
So that was what kind of I started thinking about. And I believe there is some work that has been done. I don't know if it's published or not, where there have been people looking into how fair ontologies are in the biomedical space, at least. So people have been looking into that.
We'll definitely try to search along those lines, and if you know of those studies, we'd love to take a look at them.
Okay, so I can
we're-
see if I can find those. Yeah.
And we're definitely aware of BioPortal, and I think it's definitely an exemplar of success. I think unfortunately in the materials community, there hasn't been an effort like that that's reached the critical mass of community adoption the way BioPortal has.
Yes.
And you also mentioned sort of in your domain, you have privacy issues with patients and whatnot. And we have similar restrictions, but for a different reason. So at the end of the day, a lot of the work going on in materials design and materials optimization is done in proprietary environments. Companies that are working to develop a new material that will have a competitive advantage. So a lot of our customers or stakeholders are ones who want to leverage semantic artifacts secretly, right? And leverage data, public data, and combine it with their own proprietary data in secret.
I see. So then many of the issues that one would expect to find would be similar. So there is definitely a lot of okay. Yeah, so let me find the papers if I can and
Thank you.
plug that in.
And I'll ask if any of the other co-chairs or participants would like to add their thoughts and reactions to the conversation we just had.
Yeah, no, I totally agree with everything that has been said. Yeah, and that totally. Yeah, I mean the issues about the this very dispersed nature of data but also of the semantic assets is definitely a big issue. There is a kind of a combination of a lack of semantic assets and great dispersion of them across different fields and collections and so on. So it's really hard to find, and then a lot of reinventing the wheel kind of things as well, people starting again on the same topic. And definitely, as Zachary said, generally a lack of, in many cases, a lack of sharing of data, especially in the industrial domain, which, yeah, I mean, there's the aspect of using the metadata for the purposes that you said, Zach, and but also I would say that it constitutes an opportunity for improved sharing of knowledge, at least. So, typically, if you are formulating a material for usage, I mean, that could even be medical usage, like, for drug delivery, let's say, then the person that, quite often the ones that do the formulation will buy chemicals and materials from a supplier, but they would not know necessarily even the structure, the chemical structure of these materials. They would just know what their function is. So that as an example. So yeah, there's a lot of that type of thing.
So are there established repositories for materials which potentially would then be consumers of these semantic assets, right?
Yes, I mean, there are in the research field, this is obviously growing, and there is a lot of effort to create, for example, in Europe, so-called data spaces that provide better collections of the existing data, yeah, or of new data. There's quite a strong organization of data sets from the computational materials communities, and apart from that, the biggest data collections of materials data are proprietary. So I mean, you can are licensed. You can access them by license fee, but not typically. But typically, you would be restricted in what you can do with it.
I see.
So yeah, it definitely has a lot of issues in terms of data sharing the field. Yeah, but I mean that's kind of my view.
All right, why don't we move on to the next question? What makes a semantic asset interoperable? Would anybody like to react to what's been written? A lot of great things got written down. So some of the things that got written down, use of community or known standards, so it's easy to connect to others, but still requires work. Interoperability does not happen automatically. I agree with that. It takes expertise to make those connections and those crosswalks. Another mention is rich annotation of the asset itself. For example, using DCAT in each of the terms and concepts with reference to existing standards and resources. Clear definitions of the terms themselves to enable crosswalk and disambiguation when identical terms or words are used but have either different or similar definitions. And of course, mention that these things need to be serialized in a machine actionable format. And some examples like JSON and RDF were given. Use of well-established vocabularies or standards or mappings of those that are available or associated with the asset. And of course, if anybody thinks of things after the fact, they're welcome to continue to add bullets to the other sections of the collaborative notes. All right, so let's move on with the last one. What makes a semantic asset reusable? So some things that have been said so far, good documentation, so humans know how to implement that semantic asset in code. Licenses, of course. A lack of license is problematic and will inhibit reuse, so it's good to have known permissive licenses. Another shout out to documentation. So that way, and good metadata for machines. Something that's being written is good examples. I think that's a good suggestion. Human-friendly examples. Oftentimes, I think many people find it easier to work from examples than the documentation itself. And easy tests. I think what that means is sort of verifying and validating that your semantic asset meets the criteria. And I think a good example of that, and I'll go ahead and add it, is like schema.org has a validator. I've used it myself, where you can easily just copy and paste in a bit of JSON, for example, and you get sort of an assessment of how well you're doing in using the specification. So some clarify. Would somebody be willing to unmute? There a bullet got added, sort of clarifying, and or maybe that's just an open question, like how open does the license need to be, and maybe that's just something the group needs to provide a recommendation on. I think that's a good question. I've certainly heard concerns that certain kinds of licenses are not attractive within industry, that some licenses are not permissive enough. So that's something we can dig on as a group. And if anybody would like to unmute, they're more than welcome to. All right, let's go ahead and move on to open discussion. So first, it's been written down. What are the mechanisms for disambiguation? It'd be great if somebody would like to elaborate on that, either in the notes or on muting if you feel comfortable. And general reactions are welcome. We would love to hear your words of wisdom, words of caution. We certainly don't want to get into a situation where we're trying to boil the ocean. We want to keep our working group focused on the achievable. So your reactions, your opinions, your thoughts are helpful. So I'm going to add an element that I'd love to hear people sort of expand on, and that's education. I think one of the things that I think may be an inhibitor in our community is awareness of the fair data principles, awareness of how to make how to do data curation, data publication. It'd be great if folks would sort of add their thoughts on that. And something we'll do in a few minutes is somehow our template got a little wonky, and we'll revisit this question up here. in a few minutes. So we're getting a lot of great discussion on harmonization and what does it mean and how do we do it. And so let me read some of these. I think that structure of the data can reduce ambiguity of vocabulary, especially in the material science, where a wide range of materials of different characteristics are involved. Well-designed data structure would be essential for harmonization. So is harmonization use case dependent? Is it useful to annotate source terms with these use cases so others can see how they are used in different data structures? These are all wonderful points. Some questions around can we do a schema.org for materials? And I think that's a great question, a great idea. That certainly happened with bioschemas, and it started out as sort of a separate entity from schema.org, and I think it eventually got rolled into mainline schema.org. But there are questions like what's the minimum metadata to make that make sense? Could fair semantics be improved if different semantic assets refer to that agreed set of minimum top level? I think that's a great question, a great thing that I think this group could work on, I think in stream C. Ooh, great. We've got some comments coming in for the education. That's a great question. When would the greater workforce in encounter semantic artifacts. That's something I personally struggle with. I think in an ideal world, these semantic artifacts would be sort of embedded within the tools that we're using, like much the way when we use our smartphones, our laptops, we're benefiting from TCP/IP, but it's at a level that we're unaware of the benefit that we're getting from it. Unfortunately, I think the materials community is in a transition where it's not embedded within our tools. So I think more people have to have awareness before they can benefit. Then the next point on education, it's important, and a suggestion that we focus, or maybe a comment that their effort in NFDI is focusing on the early career researchers. So in NFDI Mat work, they worked on fundamentals of scientific metadata as a course tailored to material science, and we've got a link. Thank you for that. So I'd like to transition back up. So right above the open discussion, there was a bullet that got misplaced, and we accidentally had two open discussion bullets for a moment until I got rid of one of them. So for the material sciences, what would constitute a vocabulary or semantic artifact that fulfills the role envisioned by FAIR indicator I2, where metadata use vocabularies that follow the FAIR principles, and also sort of follows the FAIR indicator R113. Data and metadata meet community relevant standards. So please list the characteristics and examples from other domains. And Gerhard, if I didn't explain this question quickly, please jump in. And some of the examples from last week on this question. So compatibility and interoperability with other vocabularies in the domain. EMMO as a top level. Most ontologies and chemistries are somewhat BFO compliant. So we'd love your reactions on this one last question. And apologies for asking this one after starting the open discussion.
No, not at all. I think it's a good way around it. Hopefully, since we've already discussed and elaborated on a few of the points that play a role here. Yeah, I mean, it could be. I mean, in a way, it elaborates. It's just on the same points, but maybe you have any kind of examples. These, of course, the vocabularies, themselves have to be fair, and we elaborated that, but quite often there are. Also in the previous session on the World Fair, I think, I'm not sure who attended that. There are these, then the resources that each field use, and again, our issue is often that we have no clear go-to thing, right? So it's not like, okay, there's the IUPAC Gold Book in chemistry or something like that. So, but maybe you have the sort of, I guess there's also attempts therefore to kind of establish these types of resources in Kwang. I think if you're still here, and maybe these sort of metadata developments that you're working on, maybe you could say a few things on that. Is to give people a vocabulary that they can use. Is not because that's often the question, right? I mean, there's the people that develop the ontologies and the stuff like that, but then there's a disconnect between that these communities and the communities that have the data, and then they scratch their heads and don't know what to use.
A question that got added in the the open discussion: are there issues with translations for materials description? I would say that materials descriptions in general, whether they're for humans and machine, are really challenging, just because materials structure and materials property spans so many different lengths and time scales over which processes or structures occur. So I would say in general, describing the processing history of your material, the structure of your material at various length scales is in itself a challenge, and why we're in progress has been so slow in the materials community. I would argue progress has been a lot faster in the computational sciences, or computational material science, and much slower in the experimental material science.
And that's a good point. I guess as you kind of indicated in computational material science, one of the reasons is that in a way the problem is more well defined or better defined, you know, and then hence it kind of is easier to do than, yeah, with experimental side.
All right, so we have about, I don't know, 19, 18 minutes left, and we want to see if we can get some volunteers for either stream A or stream B. So stream A is collect and review fair maturity assessment of existing semantic artifacts. So making us aware of semantic artifacts that exist, helping out with sort of defining what fair maturity means for those things, and assigning sort of a metric of their fair maturity. So if you're interested in helping out, please add your name to the list for stream A, and likewise for stream B, which is developing those best practices for practitioners to achieve fair data based on these terminologies. So if you're willing to sign up, please do so. In the remaining 15 minutes or so, I think we'll just keep the open discussion going.
Here I have a very, very fundamental questions like to discuss.
Yeah, go ahead.
Everybody. Yeah, with everybody. Yes, from the point of view of application of data in our material research, generally people like to mention about the composition, processing, microstructure, and the property, and so on, in the relationship between among all of them. It's the key point for the research. So at least the student around me have no much idea about the semantic term, and even have no interest in metadata. So for them, it seems that there are parallel. That's the research, it is research, but the data is data. So how to make the education to bridge the gap among them for the common students. I have no idea if the student in US and Europe, that the students of material science have a very strong knowledge about data and database and the data knowledge and so on. But at least in China, most of the students from material science had no idea about that and no interest in it. And now they have a great pressure from machine learning, and they concern much about how do we can get the data only focus on their own research. They have no interest in other fields. So this is the current situation, at least around me, among the students. So this is the difficulty, I think, for me as a researcher to push them to focus on this one. This is just my very basic question. I'm not sure if you have some questions on this one.
I definitely understand what you're saying, and I think what you're sort of describing is the necessary culture change that has to occur in moving from where a state where people are working on the process structure property relationships without a big emphasis on data. And I think you accurately pointed out that the massive change that's going on with machine learning and artificial intelligence is now a great incentive and driving force for that culture change, because as we all know, machine learning and artificial intelligence, data is the fuel to empower those methods to give useful solutions. So I think it's really timely that this group is going to work on this problem, and I think provide the resources that with that driving force coming from an artificial intelligence, machine learning, to make meaningful change, meaningful culture change, and bring in meaningful solutions. So it's definitely, I think, on our minds.
Okay, thank you.
Would any of the other co-chairs or audience members want to sort of react to that conversation?
Yeah, no, I think it's a great point that you made. It's kind of from the sort of more passive. I mean, what I have. I mean, okay, it's a long time that I worked in academia, so but I did in the past in the material science department in Cambridge, and of course, you know, based on the background here, methods going back to Mike Ashby in terms of material selection are long-standing and were always part of the teaching, but so using materials databases and materials data for analyzing materials was, you know, part of the curriculum. On the other hand, I would say that this was more of a kind of, I mean, kind of passive relative to data, right? I mean, you were sort of designing with some data, using the data, but it was not, you know, the data were already in a database. The data were in, you know, organized by a schema. You just use these data according to a certain way, right? But there's no way of then, let's say, combining that with your own data, not so easy at least, and so on. So this is developed, and I think, as Zach said there, it creates real incentive to be more actively involved as a result of the availability of the machine learning and AI tools. So yeah, which provides both a tool and a motivation. Yeah.
So there's
I totally agree with your comment about we also definitely need a change in the culture, and also we have to prepare very well environment for the student can easily access the data in in bulk amount. But I think that in order to do that, I think our effort is very important to, to change that kind of cultures, because that kind of culture, the change of the culture should start from the benefit they can experience with the present data. But in my viewpoint, the present database, any present existing database is not suitable for the machine learning research. They have to manipulate. They have to, curate the data stream, because they have to draw. They have to use large effort to do that before they're doing the training. So I think we should build very, the very efficient data structure or terminology and whatever it is. I think so. We have to suggest a kind of a guideline how material data should be collected. What is the ideal data structure for machine learning study? Then people feel the benefit from this kind of databases, then they will change their mind and they will contribute more. I think that is some initial, the initial trigger for the culture change in our research community.
Yeah. I mean, the other thing is in our field is, of course, is the complexity of the data, which leads to data being in very hard, even machine hard accessible type of forms, right? So of course the first thing is that almost everything is not just a number, right? I mean, everything is kind of fields, arrays, and whatever. Then these exist under certain conditions, and of course, the traditional way of using spreadsheets is not even a CSV format, right? Because someone writes a line somewhere, and then underneath is a kind of a table. So they're basically tables and not really machine readable. And the reason for that is typically because you want to express a certain background and complexity of what this table represents. So it's very difficult. Yeah. And so the mixture of formats is just enormous, and that means that we have to work on improving that, and as has been mentioned in other areas. I mean, it's like even in we're still trying to, one thing is we're still trying to then represent things that are in a file, right? Which someone has structured in some sort of way, and this is not a to do.
Stop.
Seems, Gerhard, you froze for a brief moment.
Oh yeah, sorry.
But there's a great question in the Zoom chat to sort of what are the next steps for the streams, and I think that's a great sort of segue into sort of wrapping up this plenary session. So I'll answer that for the next steps overall for the group. So the group chairs will meet next week and sort of respond to the questions of how this plenary session went and provide that to RDA. Also, we're going to try to meet next week in the same meeting and draft a proposal for the 23rd plenary meeting in Costa Rica. So if you'd like to be involved in the meeting, the 1 hour meeting next week for wrap up this plenary and plan for the next one, just reach out to one of the chairs and we'll try to make sure that you get that meeting invite. Other next steps, I think this working group needs to set up a monthly meeting where it's publicly announced that on the RDA website when our monthly meeting will be. And I think what will happen is the streams will work asynchronously and these monthly meetings will serve as sort of regular progress and coordination on a live call for that asynchronous work. And then hopefully between now and Costa Rica, those streams will make some progress. And I'd invite the other co-chairs to provide their input on what they think the next steps are going to be for the working group. And thank you, Athena. Yes, please sign up. There's a website. Obviously, the Research Data Alliance is going through a bit of an overhaul, but it should be possible to sign up to the group and get the emails.
Yeah, absolutely. I mean, just to again maybe reiterate and point to the case statement, and Zachary, you showed also the slide from that with the streams work program. So what we tried there is, really to show the Gantt chart or whatever you want to, the timeline. And of course, we will discuss that once we start the streams. But the idea is that we want to keep to that as much as possible. Obviously, otherwise we won't be able to achieve what we wanted to achieve in the time given, and that's the limitation, but also the guide for the working groups to keep things reasonably contained. That doesn't mean we can't have these types of discussions along the way, but that takes us back on track, hopefully.
All right, with that, I think we can start wrapping up the session. So again, please, if you're interested in this group, sign up through the RDA website. If you know people who would be interested in this working group, please advertise for us. A huge thank you to Ryan O'Connor and Athena. Their support has been absolutely amazing. I didn't have to do a lot of work to prepare for this session, thanks to the hard work of Athena and Ryan. So a huge thank you to them. A huge thank you to the co-chairpersons of this group, some of whom have joined these calls either under the weather or at unusual hours. And of course, thank you to all the participants who were able to join this call today and contribute. So with that, I think we can close out the session. And if you'd like to unmute and give a round of applause for everyone, or use the digital version inside of Zoom, let's give a nice round of applause to all the participants and of this session. And I think this basically wraps up the plenary. This session is, I think, one of the last ones of this virtual plenary.
It is. Thanks a lot, everyone.
Thank you.
Wherever you are in the world, good afternoon, good evening, good morning, and thank you.
Take care.
Exactly. Thanks a lot, everyone. Bye.
Bye.
So we'll be closing this meeting. Thanks a lot, everyone. Thanks, Zach and all.
Thank you. Bye.
Bye.